Hello everyone, in this video I'll be explaining you the problem maximum matrix sum. Okay, so you're given integer and n cross n you're given an n cross n integer matrix. You can do the following operation any number of times. What is the operation? Choose any two adjacent elements of the matrix and multiply each of them by -1. So two elements are considered adjacent if and only if they share a border. Okay, and what is border? Your goal is to maximize the summation of the matrix elements. Okay, we have to maximize the summation of the matrix element. Return the maximum sum of the matrix depend elements using the operation mentioned above. So what is the border? Border is I'll tell you on the board. Yeah, let's take this example. We have 1 minus 1 minus 1 1. Okay, let's go to the board. So this is a good problem. So looking, yes, so we have 1 minus 1 minus 1 and 1 in the array. Okay, array or matrix you can say. So in the question what they've said is we have given n cross n matrix. Okay, so it is an n cross n matrix, which means we have n rows and n columns, right? And we have integers in the matrix, and it may be negative also, positive also, 0 also. Okay, so now the question what they've asked is if you consider this as a matrix, okay, this is 0 row, first row, 0th column, first column. If you take this element 0 comma 0, so its adjacent elements are, okay, this is border. Okay, so its adjacent element is this, let me call it as 1 2 3 and 4. So one's adjacent elements is 2 and 3. Okay, so this is border and this is border. Okay, so if you consider 4's adjacent elements is 2 and 3. So if you take a bigger matrix, let me draw which looks like matrix. Okay, 1 2 3 4 5 6 7 8 9. So if you consider 5 element, so it has border with 2, so 2 and 5 are bordered, so we can multiply these two elements by -1. Okay, even this is a border 5 and 6, this is a border 500, and this is a border 4 and 5. Okay, so now the question what they're saying is we have to maximize this sum of this matrix, maximize this sum. Okay, we have to find the maximum system using the operation. The operation is that we need to choose the adjacent element, any two adjacent element, two, okay, only two elements, and we can multiply it by -1. Okay, so let's say we have 2 here, so its value after multiplying with -1 is going to be -2, and then 5 also is going to be -5. If let's say here have -2 and this is 1, if you multiply with -1, so its elements is going to be this is multiplied with -1 and this is multiplied with -1. So -1 into -2, if you do, it is +2. So basically whatever sign is there, that is going to change. So now you may be thinking how to solve this, right? So you can apply brute force approach. So I will not be solving brute force approach. The reason being is that the brute force, I mean, for this problem brute force is kind of complex, and n is 250. So yeah, we can we can think of this is kind of more of implementation problem. Okay, so if you solve problems in code forces or code chef, or add code or something like that, so you can find the pattern. So one thing is that what you can do is they are asked you to find the adjacent I mean the maximum sum. So if you simply find the sum of this sum of this is going to be 0. Okay, so in order to maximize this sum, your goal should be whatever the negative elements are there, that has to be made into positive. It makes sense, right? because positive elements will contribute to the sum, but negative is reducing the sum. So now so we need to focus more on negative elements. Okay, we need to focus more on negative elements. If let's say we had array of this way -1 and 1 1, so since both elements are adjacent and both elements are negative, if you multiply these two with -1, it is going to be +1, right? And both are contributing to the answer. This makes sense. What if it is in this form? If it is in this form, we try to make sure somehow the negative elements, two negative elements, we bring to them adjacent. Okay, we bring to the adjacent. Let's say I multiply these two with -1, so it is going to be -1 and this will be +1. Okay, and we have -1 and this is +1 only. Now I brought these two adjacent, I will multiply it by -1 and this is going to be this thing. So now first thing, we have to focus more on negative elements, and second thing is that we need to bring this negative element to the adjacent. So now one more observation I will tell you. 1 2 3 -1 -2 -3 1 2 3. Okay, let me try to tell the other observations. So we have 1 2 3 -1 -2 -3. We have 1 2 3. In the previous case, if you had seen, the this was the case, right? 1 -1 -1 -1. Okay, so the negative elements in this were two negative elements were, it's like even, and we directly converted to positive elements. Okay, both the elements was converted to positive elements. Now in this, if you see these two, if you take adjacent elements, it is going to give you 1 2 3 1 2 -3 and 1 2 3, and if you calculate the sum, it is going to be 6 plus 6, which is 12. Okay, but if you take these two as adjacent elements, what will happen now? 1 2 3 -1 2 3 1 2 3, and 12 plus 5 is 15. So obviously this is greater sum, right? So obviously, like, whichever has the absolute value, right? We are, first thing we need to focus on negative elements. We have 3 negative elements, and if there are 3 negative elements, you can't convert all this into positive, because you need 2 elements in an adjacent to convert that into positive. Okay, so these two can be converted, but this you cannot. And why this cannot? Because this has an absolute value of lesser. So I want the sum to be greater, so I want the negative element to be as large as possible, negative element as large as possible, or in other time, the absolute value of the element to be as small as possible, right? The absolute value of the element to be as small as possible. So absolute value of this is 1, this is 2, and this is 3. So obviously this is small, so I will make sure only this remains in the array, and these two is like can be converted to positive. Okay. Now when you have converted this, it is positive, so no matter what you do, now this -1 remains as it is. One thing I just wanted to tell you, that this -1, whatever is that, this minus can be can be put in, this minus sign can be put to anywhere. How? Let's see, if you take these two elements, minus will come here, it is plus. If you take these two, it is plus and this is minus. If you take these two, this is minus and this is plus, right? Because I'm doing the operation that they have said. You need to multiply those elements by -1. So this minus, wherever it may be, like in this example it was -1 only, but let's say you have this example only, where you have minus at 3 and all other elements are positive. Now you want to make the sum greater sum. So whatever sum you are getting here, -3, if you do, that is larger, right? That will reduce the sum. And if you try to take that minus to the absolute minimum value, which is here 1, how can you do this? These two are adjacent, this is minus, right? If you are doing -1 operation, now take these two adjacent elements, so minus minus plus, and this is minus. So you have brought to the lowest value, and you have got the highest sum. So you do that way. Okay. And what if let's say you have element as 0, one of the 0 or something like that, and you have minus this at this position. Now in this case what will happen, you can put this minus to 0, and minus 0 plus 0 doesn't make any sense. You choose these two elements, this will be minus, this is plus. You choose these two elements, it is plus, it is minus. You choose these two elements, I'm doing just operation, right? This is plus, this is minus. Choose this element, this is plus, this is minus. So minus 0 doesn't make any sense. So in this case the sum is entire thing. Okay, so this is the observation. And first observation was that you need to focus on negative elements. If there are even negative elements, you can convert all the negative elements to positive elements, because wherever it is minus, you can make sure that minus comes to other position, and you put to the adjacent side, and then make the operation which makes the positive element. And if there is an odd number of minus, if there is an odd number of negatives, okay, so in that case only one that odd number whatever you have, except that you can convert all the other elements to positive. Okay, and one element that you will be choosing is the smallest element in the array, and smallest element is that absolute smallest element. Okay, not the direct smallest. If you take direct smallest, in this example it was like one this thing, right? So the absolute value would be minus 3, I mean direct value. Okay, minus, this is the smallest possible, but absolute smallest is 0. And in this sum I'll tell you the entire value sum is like maximum sum, right? Maximum sum is going to be sum of plus equals to absolute value of entire this elements, each element taken, because you take these two as adjacent, multiply, it will be a plus. Okay, now these two as adjacent, this is plus, this minus, so minus 0 is like nothing, so it will be all positive. So if I try to write the pseudo code, what will happen? We need to first focus on negative elements. Okay, first focus on negative elements. Basically what you have to do, count negative elements. Okay, count negative elements. Okay, we'll be counting negative elements, and at the same time we need to add absolute elements, okay, into some variable, assume some variable, okay, or any variable you can take, answer, something like that. The reason why I'm saying is, if this negative count, I'll make it count only. If count modulo 2 equals to 0, since we have even number of negative elements, if that is the case, then those negative elements can be made positive. So in that case your answer is directly sum. Okay, your answer is directly sum. Else if we have, let's say, negative elements, so we need to keep track of smallest element as well. Okay, smallest element you need to keep track of. Your smallest element is going to be absolute value of elements. These steps I'll be telling you how to find the smallest element. So once you find that, it's like when you have negative element, so your answer is going to be sum minus 2 times the smallest elements. Why 2 times? I'll tell you. Okay, this is the algorithm. Let's say we have minus 1 1 1 1. Okay, so in this case, if you see, the count of negative elements is just 1, which is odd. If odd is there, we need to find the smallest value, and or let me take it as 2 and 3. The smallest value in this is 1. Okay, smallest value, why I'm taking smallest, will be 1, not minus 1, it will be 1, because absolute values I'm taking. Okay, this is 1. Now if that is the case, if you try to sum, we have 6 as the sum, total sum of the array. If you're taking since this it is these 3 elements sums to 6, okay, and this element you have taken it as positive. You have taken it as positive. Now because of that your sum is 7. Total sum is 7. But actually, if you see what is your sum, 2 plus 3, 5, and these will be cancelled. So your sum has to be 5. But whatever absolute value you have taken absolute value of 1 plus absolute 2 plus absolute value of 1 and then plus absolute value of 3. So your sum was actually 7. So whatever smallest element you have, we just reduce it one time because you have added it as a positive. Okay, so understanding right what I'm trying to say. um, See, this is like you have added all as a absolute value, so sum is 7, but this one you have taken it is positive, but it is actually negative. So one time you will have to subtract. When you subtract one time, it is going to be 6. Okay, because you had made it as a positive, that's why one time is subtracting. But now you are subtracting because its actual value is -1. It is 5. You take any example, you'll get to know. So this is the algorithm that I'll be uh, using to solve the problem. Let's try to code it up. First thing first, I'll take hash define ll as long because long I'll not be writing multiple times. Our answer is 0 initial, I'll say, or you can say sum is 0. Now I'll take one int variable as smallest will hold the smallest element. Initially let me initialize it as max. I'll take n as the size of the matrix. It is a square matrix, that's why your size should be n cross n. I'll run 2 loops. What I'll do is I will add to the sum absolute value of matrix of I comma j. Okay, and your smallest value is going to be minimum of smallest comma absolute value of matrix. I'm taking absolute values only. Okay, and I'll take count variable also. Okay, int negative count, which is initialized to 0. I will check if matrix of I comma j is less than count. So it's like negative element, so I'm increasing negative count. Okay, I need to check if this negative count is having odd numbers. So it's like one element you can't convert it to positive. If the smallest element is 0, so in that case -0 you'll be subtracting, so it is like sum minus equals to 2 into smallest. So if it is 0, so you're subtracting nothing. It's like okay, if it is some negative element, so you'll be subtracting. And since smallest is having absolute value, so it will be positive only. Okay, return sum. Let's try to run it. What is happening? Acha, it should be negative count. Sorry, it should be less than 0, not negative count. If grid of matrix I comma j is lesser than 0, which means it is a negative element. And here smallest is integer and absolute value. Achha, it's not matrix, it's matrix of I comma j. Okay, so it is running fine. Let's try to submit it. So yeah, it got accepted. And if you try to analyze the time complexity, it is just n square because we're using for loop, and then space we are not using any, we are using this constant variable, so it is a constant. So yeah, thank you guys for watching the video.